On the first day of spring, parts of the United States did not feel like spring at all. They felt like a season that had arrived far too early and far too aggressively. In Denver, the air climbed into the mid-80s. That is not just warm for March. That is not a pleasant anomaly, not a quirky afternoon, not one of those strange little weather moments people laugh about and then forget. That is a June temperature showing up on the calendar while the country is still supposed to be easing out of winter. And that is the first reason this story matters. The atmosphere is not just running hot, it is running ahead of schedule. That difference matters more than it sounds, because when a place like Denver feels like mid-June on the first full day of astronomical spring, the mind does something dangerous. It tries to normalize it too quickly. It says warm days happen. It says weather is weird. It says records are made to be broken. But this week is asking for a more serious reading than that. What is happening across the United States right now is not simply a warm spell. It is a heat event arriving early enough, broad enough, and strong enough to force a much larger question into view. If this is what the atmosphere is willing to do in March, what exactly is it preparing to do when the real heat-building months arrive? And the heat, as dramatic as it already is only the visible layer of the story. It is the part that makes the maps glow red, the part that turns headlines into alarm, the part that people share because a single number is easy to understand. But under those numbers, the structure of the event looks even more concerning. Humidity has collapsed across parts of the Great Plains. Strong winds are moving over wide grasslands that have been drying for days. Overnight recovery has been poor in areas where cooler nights should still be providing some relief. Fire weather conditions are building over regions that, psychologically, many people still do not treat as fully inside the dangerous season yet. That is why this is not just a heat story. It is a systems story. Temperature is only one layer. Wind is another. Humidity is another. Fuel condition is another. Forecast behavior is another. And when those layers begin stacking on top of each other in the same week, the event changes shape. It stops being a simple piece of weather news and starts looking more like a warning shot. Not necessarily proof that one particular catastrophe is inevitable, but proof that the atmosphere is already capable of assembling a summer-grade threat profile before the season has properly begun. If you want a place to anchor that idea, start with Denver. Denver is useful because it turns abstraction into something concrete. Around March 19, temperatures there climb to roughly 85 degrees Fahrenheit. Now, if you are from Colorado, that may not sound impossible. Warm days happen, Chinook winds happen, sudden swings happen, but the deeper point is not that Denver got hot. The deeper point is how hot and when. 85 degrees in Denver belongs much closer to late spring or early summer than to the first day of spring itself. It is not a spring number that drifted a little high. It is a summer number arriving months early, and then you get to the more unsettling part. The forecast was already expecting a very warm day. This was not a situation where forecasters predicted something mild and reality exploded past it. The models knew a serious heat event was underway, and yet observed temperatures still came in above those expectations. A forecast near the low 80s became a reality in the mid-80s. By itself, that may sound trivial. 2 or 3 degrees is not the kind of difference that grabs attention in ordinary life, but in an event already operating near record territory, a repeated gap between forecast and reality is not a small detail. It is the kind of detail that changes how the entire week should be interpreted. A single forecast miss is noise. Weather is complicated. Local effects matter. Forecasts are never perfect. But when the atmosphere repeatedly lands hotter than expected across multiple days, and when that happens during an event that is already stressing the upper end of the seasonal range, the miss begins to mean something. It begins to look less like random error and more like a pattern, and patterns are where serious attention belongs. This is what makes the current setup more unnerving than a headline about a hot day. The issue is not just that temperatures are high. The issue is that reality may be consistently outrunning the tools built to estimate where those temperatures would land. That matters because the world does not prepare for weather based on the final observed number. It prepares based on what it thinks is coming. Utilities prepare for expected demand. Emergency messaging is shaped by forecast language. Fire response posture depends on the severity implied by the setup in advance. People decide whether to cancel plans, check on relatives, or take warnings seriously based on the version of the future presented to them before it arrives. So, when reality repeatedly comes in hotter than the stated high, even by a narrow margin, the practical consequences can be larger than they appear. The atmosphere does not become more dangerous in a neat, linear way. 2 extra degrees at the mild end of the scale are almost meaningless. 2 extra degrees when heat, dryness, and wind are already aligned can be the degrees that push an area from severe into critical. The extra heat dries fine fuels faster. It deepens physiological stress. It keeps demand higher for longer. It's overnight recovery. It makes every other part of the system just a little more brittle. That is why this is not a story about forecasters getting embarrassed. It is a story about a dangerous event finding room above the forecast ceiling, often enough to raise a structural question, not a sensational question, a technical one. Are the models, at least in events like this, running slightly behind the atmosphere they are trying to describe? The careful answer is not to say the models are broken. That would be sloppy, and it would also be unfair to one of the most impressive scientific systems humans have ever built. Modern weather forecasting remains extraordinary. These models are ingesting vast amounts of information in real time: pressure fields, moisture content, upper air dynamics, terrain interactions, solar input, cloud processes, wind profiles, and turning all of that into short-range forecasts that, on most days, are astonishingly good. 50 years ago, this would have looked like magic. Even now, it is easy to underestimate how powerful these tools really are. But powerful tools can still show a lag at the edge of the distribution, and that may be what matters here. The more unsettling possibility is not that the science has failed, it is that the atmosphere may now be visiting states near the extreme edge, often enough that the historical climate envelope used to calibrate the models is becoming less representative of what is happening in real time. The math can still be correct, the physics can still be real, and yet the system may still lean slightly conservative at precisely the moments when the upper edge matters most. That is a much deeper kind of warning, because it suggests the problem is not mechanical failure. It suggests the problem may be historical anchoring. Forecast models are built from physics, yes, but their best practical performance depends on tuning, calibration, and correction against long records of observed atmospheric behavior. Those long records describe a world that existed. The question now is whether that world is still fully describing the one unfolding outside the window. If the atmosphere is spending more time near very extreme ridge states, very high early season heat, very aggressive dry air setups, then the models may still be summarizing the past a little better than they are capturing the newest edge of the present. Not by a lot. Not enough to make forecasting useless, but enough to matter. Enough to mean that the stated high, in a dangerous event, might not be the top of the story. Enough to mean that exceptional conditions can still overperform. And that changes the emotional meaning of the entire week, because now the story is not merely that the United States is hot in March. The story is that March may already be producing a style of heat behavior that belongs to another part of the calendar, while the predictive systems meant to map that behavior are arriving slightly below what the atmosphere is actually willing to deliver. That is what gives this event its particular edge. It is not just the number on the thermometer. It is not just the map color. It is not even just the records being approached. It is the possibility that the atmosphere is revealing something larger about the season ahead. It is showing, very early, how high it can climb. It is showing how quickly spring can lose its old identity and begin acting like something far more dangerous. And it is doing that before the longest days, before the deepest summer dryness, before the strongest seasonal heat engine has fully come online. So the real point is not that Denver felt like June. The real point is that June-like behavior showed up in March and then kept exposing the same uncomfortable pattern. The atmosphere was not merely extreme, it was slightly ahead of what people expected it to be, including the systems built to forecast it. And once that happens for more than a day, the correct response is no longer casual surprise. It is attention, serious attention, because if early spring is already capable of this, of summer temperatures, stacked fire weather ingredients, and a forecast that keeps landing just below the lived reality, then this week is not only a weather event, it may be the opening argument in a much larger case. A case about seasons arriving distorted, a case about extreme conditions showing up before the public is mentally ready for them, and a case about what it means when the atmosphere begins the year by reminding us that our old expectations about when danger starts may no longer be reliable. To understand how unusual this event really is, we have to stop using ordinary language for a moment. Words like hot, severe, unusual, and even extreme can only take you so far before they start losing precision. And this is a moment that needs precision, because what is happening over the United States right now is not just a matter of discomfort, or even just a matter of records. It is a matter of statistical rarity. The atmosphere is not simply running above average. In several of the ways meteorologists measure large-scale heat structure, It is operating near the far outer edge of what the historical distribution says should happen. A good way to picture that is to imagine 1,000 people taking the same exam. Most scores gather in the middle, some do well, a few land near the top. But the 99th percentile is not just very good, it is the thin upper edge where almost nobody lives. It is the kind of result you remember because it stands apart from the rest of the group. When meteorologists say parts of this atmospheric setup are pressing into 99th percentile territory, what they mean is not simply that conditions are impressive. They mean the atmosphere is behaving like one of the most exceptional students in the room, and it is doing that in March. That last part matters more than almost anything else. If you heard those words in late July, you would still pay attention, but you would at least understand the season had access to the strongest sunlight, the longest days, the driest landscapes, and the most mature heat patterns of the year. Summer is the part of the calendar where people expect the atmosphere to occasionally reach for its most aggressive tools. March is not supposed to be that part of the calendar. March is supposed to be transitional, a month of instability, yes, but not usually a month where the atmosphere presses up against the top edge of its historical range. This is where upper air data becomes so important. Surface temperatures tell you what people feel, but upper-level atmospheric structure tells you what kind of machine is operating above them. One of the most important levels meteorologists watch is the 500 millibar level, roughly around 18,000 feet above the ground. It sounds technical, but the principle is not complicated. When that pressure surface rises unusually high, it means the column of air beneath it is warmer and more expanded than normal. Warm air takes up more space. A deeper, more swollen air column pushes that level upward, and when that height becomes unusually great, meteorologists call the feature a ridge. A ridge is not just a blob on a weather map, it is one of the most efficient heat-organizing structures the atmosphere can build. It suppresses cloud development. It reduces the chances that cooler, more unsettled air can move in and disrupt the pattern. It promotes sinking air, and sinking air compresses and warms as it descends. The result is a self-reinforcing setup where sunshine is maximized, cooling influences are minimized, and the surface below gets baked day after day. That is why a ridge should not be thought of as just a technical detail in a forecast discussion. A strong ridge is a heat trap. It is the atmosphere arranging itself into a shape that favors prolonged warming, and when that ridge reaches 99th percentile territory, you are no longer dealing with a merely strong, warm spell. You are dealing with a structure that, statistically, belongs to the rarest end of the record. In plain language, the atmosphere has built itself one of the most efficient heat engines it knows how to build, and it has done so before the warm season has even properly begun. There are also forecasting tools designed to capture this exact idea of rarity. One of them is the Extreme Forecast Index, often used in European forecasting systems to compare an upcoming event with the climatological baseline. The important point is not the name. The important point is what the tool is trying to answer, not simply whether the event will be hot, but how far outside the ordinary envelope it is likely to fall. That distinction matters. An event can be above normal without being particularly important. But when a forecasting system starts flagging an event as sitting near the outer edge of what it considers historically extreme, the tone changes. And then there is an even more unsettling layer. Some diagnostics do not just ask whether the event is extreme, they ask whether the event is pushing beyond even the model's usual upper expectations for extreme behavior. That is where people sometimes refer to the tail of the distribution, the thin edge where the rarest outcomes live. If the atmosphere is not only reaching that tail but leaning against it, then the system is telling you something very specific. It is telling you that the event is not merely unusual in a broad human sense. It is unusual in the mathematical sense used by the people who build forecasting systems to define the limits of what is typically seen. A useful way to imagine this is with a ruler. Think of the historical climate record as a ruler built from decades of observation. It contains ordinary summers, memorable summers, major heat waves, outlier events, and the worst cases people still talk about years later. Most new events fall somewhere on that ruler. Some land near the high end, but every now and then, an event does something stranger. It does not break the ruler in half. It does not make measurement impossible. It simply begins to lean against the very edge of the marks already printed there. It reminds you that the measuring tool was built from the past, and the present is now testing how far that past can still stretch. That is what makes this moment so hard to dismiss. It is not just that the atmosphere is hot, it is that the atmosphere is operating with a kind of reach that should make people sit up. And once you understand that, the central question becomes unavoidable. If this is 99th percentile atmospheric behavior in March, then what does that imply for the months still ahead? That is not a dramatic question. It is a practical one. Because summer has not yet fully switched on, the sun angle is not at its annual maximum, daylight duration is not yet at its peak, the land has not yet endured months of cumulative drying. Some of the strongest seasonal amplifiers that usually help build the year's worst heat are not even fully engaged. And yet the atmosphere is already acting as though it has permission to reach near the top shelf of its own historical range. There is no comfortable way to interpret that. It does not guarantee disaster in July. It does not mean the rest of the warm season will be uniformly catastrophic. But it does remove a certain kind of comfort people normally carry into spring. The comfort that says there is still time. The comfort that says the most dangerous version of the season has not arrived yet. The comfort that says the atmosphere is still warming up. Because what this week suggests is that the atmosphere may already be far more warmed up than the calendar implies. And once that thought enters the story, March stops feeling like a transition month and starts feeling like a warning month. A month that shows you what is now possible before the real furnace of summer even opens. That is the part people should sit with. Not just that records may fall. Records always fall eventually. Not just that the event is rare. Rare things happen. The deeper point is that the atmosphere is demonstrating its capacity early. It is revealing the upper edge of what it can do before many of the usual seasonal ingredients are fully in place. And that forces a harder question than, how hot is it today? It forces the question that should be quietly following every map, every forecast, and every new temperature reading now coming in from the American Western Plains. If this is March, what is July? Because July is where the system normally has its full strength. July has the longest memory of heat built into the land. July has the mature dryness, the stronger solar input, the exhausted vegetation, the deeper seasonal stress. July is when extreme heat is supposed to look fully like itself. So if the atmosphere is already comfortable behaving like this before then, there is only one responsible conclusion to draw. The ceiling may be higher than people thought, and the season may be arriving more aggressively than the calendar still suggests. And uncertainty does not make that conclusion less serious. In fact, it may make it more serious. There are moments in risk analysis when not having a complete answer is not reassuring. It is part of the warning, because the lack of certainty does not mean the threat is small. It means the system may be moving into territory where older expectations no longer guide us cleanly. The atmosphere is showing us something before the season is fully formed. It is showing that extreme behavior can appear months early, with a level of organization and persistence that does not belong in the mental category most people still assign to spring. So this is not just a question about today's heat. It is a question about the shape of the months ahead. It is a question about whether the old seasonal sequence is still the one people should trust. And it is a question about whether what used to be considered the outer edge of summer behavior is beginning to show itself earlier, faster, and with less warning than the systems around it were built to expect. That is why this part of the story matters so much. The atmosphere is not merely hot, it is statistically rare, structurally organized, and arriving out of season. And by the time you understand that, the story has already moved beyond a March temperature map. It has become a question about scale, not just how hot this event is, but how large it is, how much of the country it is shaping at once, and how distorted the wider atmospheric pattern has become over the continent. Once you zoom out far enough, the event stops looking like a local heat story and starts looking like a continental deformation. That is one of the most important transitions in the whole script. A single city can run hot for reasons that are interesting, but not especially profound. A valley can trap warmth. A dry downslope wind can spike temperatures. An urban core can retain heat more aggressively than surrounding terrain. Those things matter, but they do not necessarily tell you that something larger is structurally wrong with the atmosphere. What changes the meaning of the event is scale, and scale is exactly what this week is delivering. The Southwest is being driven into summer-grade heat. The Great Plains are seeing dangerous dryness and wind. Other parts of the country are dealing with completely different consequences from the same broader upper air pattern, cooler, wetter, more unsettled conditions in places that are not living inside the heat dome itself. That is why the map feels strange even before you understand the meteorology. It does not look like one weather system moving normally across a continent. It looks like the atmosphere has pulled the country into sharply different regimes all at once. That kind of contrast matters because it tells you the event is no longer about a thermometer reading in one location. It is about the shape of the system above the continent. When meteorologists look at patterns like this, one of the key features they are watching is the jet stream. People hear that phrase often, but many still imagine it as a vague ribbon in the sky that simply pushes storms around. In reality, the jet stream does something much more important than that. It helps organize the climate structure of entire regions. It separates colder and warmer air masses. It guides weather systems along predictable paths. It acts, in a very real sense, like an atmospheric boundary maker. The simplest way to picture it is as a river of fast-moving air high above the surface, generally flowing from west to east across the middle latitudes. Under more stable conditions, that river is not perfectly straight, but it is coherent enough to keep weather moving. Heat builds, then moves. Storms form, then move. Cool air pushes south, then moves. The important thing is not perfection. The important thing is motion. Motion is what keeps local extremes from locking in place too long. Motion is what gives the atmosphere its ability to reset. But that is not what this week looks like. This week, the river has not simply meandered, it has buckled. Instead of holding a smoother path across the country, the jet stream has developed a highly amplified structure, with a strong northward bulge where heat is being allowed to build and persist, and corresponding dips elsewhere that help pull cooler or more unsettled conditions into other regions. The result is a national map that feels exaggerated, like someone took the ordinary gradients of spring and stretched them too far. That is why the event seems larger than a heat wave even before you get to the fire risk. When the jet stream becomes highly amplified, the United States stops behaving like one season spread over many states. It starts behaving like several competing seasons jammed together on the same map. In one region, people are staring at temperatures and humidity levels that belong to the dangerous heart of summer. In another, the story is cold, rain, or late snow, or flood pressure. The contrast itself becomes part of the warning, and that warning is not merely aesthetic. Sharp contrast across a continent reflects stored energy and organized structure in the atmosphere. The atmosphere has partitioned itself. It has built zones of prolonged heat, zones of instability, zones of cold intrusion, and it has done so in a way that holds its shape long enough for people on the ground to experience not just a strange day, but a strange pattern. The deeper story, then, is not, why is this town so hot? The deeper story is, what kind of upper air architecture is keeping so much of this map locked into extremes at the same time? That question leads directly to one of the most important concepts in the entire event: blocking. Weather becomes dangerous not only when it is intense, but when it refuses to move. That is the transition from an event that is dramatic to an event that is compounding. A single hot day can be memorable. A hot pattern that stalls becomes dangerous in a much more serious sense. It dries the ground longer. It raises overnight lows more often. It stretches human bodies, electrical systems, and emergency response further with each passing day. It turns what could have been a sharp episode into an accumulating problem. A blocking pattern develops when a high-pressure system slows down or becomes nearly stationary, resisting the normal eastward progression that should eventually carry it away. Instead of passing over a region and releasing its grip, it parks. Instead of weakening on schedule, it lingers. Instead of allowing the atmosphere to reset, it keeps pressing the same conditions onto the same landscape day after day. That is what makes blocking so important. It changes the question from how intense is this to how long is this going to keep doing damage. And in atmospheric risk, duration is often more dangerous than the single peak. Human intuition is not especially good at understanding that. People naturally focus on the highest temperature, the strongest gust, the most visually shocking image, but systems fail more often under persistent stress than under a single spectacular spike. The body can sometimes survive one brutally hot afternoon if the night cools off enough. Vegetation can survive one dry, windy day if moisture returns. The grid can absorb one high load period if the stress relaxes. Fire crews can exploit a temporary shift in conditions if a dangerous window closes quickly. Persistence removes those recovery windows. A blocked ridge turns the night into an extension of the day. It keeps minimum temperatures elevated. It lets fuel continue drying. It maintains heavy electrical demand. It extends the time crews must work under dangerous conditions. It narrows the number of moments when the system can catch its breath. That is why the phrase "the heat dome has not moved" should land so heavily. What matters is not just that the ridge formed, it is that it stayed. And the longer it stays, the more it changes the meaning of every variable below it. Dryness is no longer just today's dryness. It becomes cumulative drying. Heat is no longer just a daytime maximum. It becomes a multi-day burden, Fire weather is no longer just a warning map. It becomes a landscape being prepared, hour by hour, for worse outcomes if ignition occurs. This is the logic of blocking. It converts severity into accumulation. That is also why so many of the most destructive modern weather disasters have involved some version of a pattern that stalled. The Russian heatwave of 2010 was not remembered because a single day was hot. It was remembered because the heat persisted and kept extracting consequences from the same region. The major European heat events of recent years were not terrifying only because temperatures climbed high. They were terrifying because the atmospheric structure held long enough for the impacts to multiply. The Pacific Northwest heat dome in 2021 became historic, not just through its peak values, but through the way a powerful ridge established itself over a region not equipped to handle that level of heat. Those analogues matter here not because this event is automatically identical to them, but because they show the same principle at work. Persistence is often what turns atmospheric abnormality into human crisis. That is the real lesson of a blocking pattern. It is not just a technical curiosity about why the map looks strange. It is the answer to why risk keeps growing even when the daily headline has already been written. And once you understand that, the emotional center of the story shifts again. The question is no longer simply whether this heat wave is unusual. It obviously is. The question becomes whether the atmospheric pattern over North America is behaving in a way that allows extremes to stay in place longer than people would normally expect in March. Because if the answer is yes, and this week strongly suggests that it is, then the danger is not contained inside the hottest reading. It is spread across time. That is what makes the continental scale of this event so important. It is not merely that a broad part of the United States is seeing unusual weather. It is that the larger structure of the atmosphere appears distorted enough to create and preserve multiple extremes across multiple regions simultaneously. One section bakes, another floods, another freezes, another dries under wind. That is not a normal spring map. That is a stressed spring map. And in a stressed map, the Southwest becomes more than just another hot region. It becomes the bullseye. Because once a strong ridge parks in the wrong place at the wrong time of year, the interior valleys, deserts, and urban basins beneath it stop behaving like ordinary landscapes. They start behaving like amplifiers. They take the broad-scale atmospheric distortion and translate it into something people can feel immediately inland. Triple digits, compressed nights, and heat that does not belong to the season at all. That is where the story goes next. Because the continental pattern explains why the event is large. But to understand why it feels so physically wrong in March, you have to zoom back in this time on the Southwest itself, where the atmosphere has found the part of the country most willing to convert a blocked ridge into temperatures that look less like spring weather and more like a rehearsal for the worst part of summer. The Southwest is where the abstraction ends. Up to this point, you can still talk about atmospheric structure, upper air heights, amplified flow, and blocking patterns in a way that feels analytical and slightly distant. But once you look at what those patterns are doing on the ground in the Southwest, the event becomes much harder to file away as a technical curiosity. This is the region where the larger deformation of the atmosphere gets translated into numbers that feel physically wrong for the month. Woodland Hills in Southern California is one of the clearest examples. Temperatures there pushed into the low 100s in March. Read that again slowly, because this is exactly the kind of detail the mind tries to normalize too quickly. Low 100s are not just very warm. They are not a spring anomaly that drifted upward by a few degrees. They are temperatures people associate with the hard interior of summer, with August parking lots, with late-season heat advisories, with the sort of afternoons when the air itself feels hostile. To get those readings in March is to feel the calendar lose some of its authority. And that is the correct way to understand what makes these numbers so unsettling. The problem is not just the value itself. The problem is the timing of the value. March still carries physical constraints that should, under more ordinary circumstances, keep the atmosphere from reaching this far. The sun angle is lower than it will be in June or July. Day length is shorter. The seasonal heat engine has not fully matured. The land has not yet spent months storing and recycling warm season energy. Even in a hot climate, those limitations matter. They are part of the reason people instinctively separate spring heat from summer heat. So when a place in the Southwest reaches or exceeds 100 degrees in March, you are not watching the season behave at the upper end of normal. You are watching multiple mechanisms line up with unusual efficiency. Clear skies maximize incoming solar radiation. A strong ridge suppresses cloud cover and keeps cooler air from intruding. Dry air allows more of the sun's energy to reach and heat the ground rather than being used up in moisture-related processes. Subsiding air beneath the ridge sinks, compresses, and warms. And then local geography does the rest. That geography matters enormously in the southwest. Inland valleys and basins are not passive landscapes during a heat event. They are amplifiers. Air descending off higher terrain warms as it compresses. Heat accumulates in enclosed or semi-enclosed inland zones more effectively than in open coastal environments. Urban surfaces, roads, rooftops, walls, concrete absorb and store solar energy through the day and give it back slowly after sunset. In other words, once the broad atmospheric setup is favorable to heat, the southwest has many local features that help turn unusual warmth into the ground is actively manufacturing more heat. That is why the region feels like ground zero in this story. It is not merely under the ridge, it is under the ridge in one of the parts of the country best designed by climate and geography to convert that ridge into extreme temperatures. And once that happens in March, the event stops feeling like a warm spring anomaly and starts feeling like seasonal displacement. Summer has not just arrived early in a poetic sense. Certain landscapes are already behaving as if they have skipped ahead in the year, but the daytime highs are only part of the problem. One of the clearest signs that a heat event is becoming more dangerous than people realize is what happens after sunset. Most people still judge heat by the hottest hour of the day because that is the number that feels most dramatic. But heat stress is not only about peaks, it is about whether the system gets relief. People need relief. Buildings need relief. Power demand needs relief. The landscape itself needs relief. And when nighttime temperatures stay elevated, that relief begins to disappear. That is part of what makes the southwest section of this event so important. Warm nights in March are not just another footnote to hot afternoons. They are evidence that the heat is not leaving cleanly. The land is holding it. The urban surfaces are holding it. The lower atmosphere is holding it. And when the night cannot cool the system enough, the next day starts from a warmer baseline than it should. That means the following afternoon does not have to build from a mild or moderate morning. It builds from an already stressed state. For the human body, that matters enormously. People can sometimes tolerate one very hot afternoon if the night that follows is cool enough to let internal stress drop. But if the body never fully resets, each day begins at a disadvantage. The next heat exposure is layered on top of yesterday's unfinished recovery. That is how dangerous heat waves do a large share of their damage, not only through the headline peak, but through the erosion of rest, the disappearance of thermal recovery, and the way fatigue accumulates invisibly from one cycle into the next. For infrastructure, the logic is similar. If buildings stay warm overnight, cooling systems work harder the next day. If surfaces stay hot, neighborhoods retain more heat into the morning. If the atmosphere never really exhales, demand stays elevated longer and system strain accumulates. This is why a heat event with compressed nights often matters more than one with a single spectacular afternoon spike. It is not only heat, it is retained heat. And retained heat is what turns a region into a thermal trap. So the Southwest matters for two reasons at once. First, it proves how far this event is reaching in purely temperature terms. The readings are not just high for March, they are seasonally disorienting. Second, it reveals how the broad continental pattern becomes personal and physical. It is one thing to hear that a ridge is strong, it is another to understand that under that ridge, nights are losing their ability to cool the landscape enough to reset the next day's risk. That is why this part of the map should not be read as a side example. It should be read as the sharpest expression of the larger pattern. The atmosphere has parked a strong, heat-favoring structure over a region that is already highly efficient at producing and trapping warmth. The result is not just an uncomfortable stretch of weather. It is a warning about what happens when early-season atmospheric extremes meet a geography that knows exactly how to turn them into something harsher. And this is the point where the story has to pivot again, because the Southwest shows what the heat can become. But the most immediate physical danger spreading across the wider region is not just the heat itself. It is what that heat is doing to the land, the air, and the fuel. Once temperatures climb this early, once the atmosphere dries this hard, and once nights stop giving enough back, the event becomes more than a temperature event. It becomes a fire setup. That is where the threat sharpens. Heat alone is alarming. Heat plus dryness, wind, and cured fuel is something much closer to ignition, waiting for an excuse. And that is the next layer of the story, the one that turns this from a shocking March heat pattern into a genuine danger pattern across the plains and interior West. This is the point where the story stops being mainly about shocking temperatures and becomes something much more immediate. Because heat by itself is only one ingredient in the kind of disaster now being assembled across the central United States. Heat breaks records, heat stresses bodies, heat strains power systems, but heat does not fully explain the danger building across the Great Plains and the interior West this week. To understand that danger, you have to look at the full fire-weather equation. And once you do, the event becomes much harder to read as just a strange early-season hot spell. Fire weather is not simply, "it is hot outside." That is the first thing people get wrong. Temperature matters, but temperature alone does not create the kind of explosive landscape behavior that emergency managers fear. For fire risk to move from serious to extreme, several factors have to align at once: heat, very low humidity, strong wind, and fuel that is dry enough to respond immediately if ignition occurs. Remove one of those pieces, and the danger drops. But when all four line up together, they do not just add to each other, they amplify each other. The atmosphere becomes efficient at turning small ignitions into fast-moving fire behavior. That is exactly why this week matters so much. The heat is already in place. In parts of the plains and the interior West, humidity has fallen to startling levels. Winds are strong enough to accelerate, spread, and carry embers. And the landscape has been drying long enough that fine fuels are behaving more like waiting tinder than living ground cover. What makes that combination so dangerous is not just that it sounds bad in theory, it is that each part of the setup helps the other parts work harder. Start with humidity, because this is where the event becomes physically easier to underestimate than it should be. Relative humidity values around 5 or 6% sound like a technical detail until you picture what kind of air that actually is. Air that dry does not merely feel parched. It behaves like an extraction tool. It pulls moisture out of grasses. It pulls moisture out of leaves, stems, surface litter, and shallow organic material. It pulls moisture out of the top layer of soil. It turns every exposed, sunlit, wind-battered surface into something a little more eager to burn. That is why comparisons to deserts keep appearing in discussions of this event. But even that can be misleading if it is treated too casually. The important point is not that part of Kansas looks like the Sahara in some visual sense. The important point is that the atmosphere above parts of the plains has become so moisture-starved that it is behaving more like the air mass over a desert than the air mass over a normally functioning temperate grassland. And once that happens over millions of acres, the issue is no longer comfort, it is combustibility. What makes low humidity especially dangerous is that it is not static. It is not just a condition. It is an active process. The atmosphere is continuously pulling moisture from the landscape hour after hour. Fine fuels do not simply become dry all at once. They lose moisture progressively. The smallest and thinnest materials go first: surface grasses, dead leaves, tiny twigs, the light outer parts of vegetation that respond quickly to changes in humidity and temperature. These are the fuels that can ignite fastest, and once they ignite, they spread flame rapidly across open country. Then wind arrives and turns a dangerous setup into a volatile one. Wind is one of the most brutal multipliers in fire behavior because it changes everything at once. It pushes flames into fresh fuel. It delivers more oxygen to the combustion zone. It tilts fire forward so heat preheats unburned vegetation ahead of the main front. It dries fuel even faster by stripping away the thin layer of moisture near plant surfaces. And perhaps most importantly, it throws embers. A fire under strong wind is not confined to one obvious moving wall of flame. It can spot ahead, start new ignitions, and outrun people's instincts about where the real danger line is. That matters enormously in grass-dominated landscapes. The Great Plains are not a terrain where fire necessarily has to fight through dense forest structure to gain speed. In many places, the fuel bed is continuous and open. Once the atmosphere has prepared it properly, flame can move with frightening efficiency. The visual simplicity of grassland can be deceptive. People often think of wildfire danger through the image of burning mountain forest. But in high wind, cured grassland can become one of the fastest moving fire environments there is. This is why a red flag warning is not just routine caution language. It is not a generic message that conditions are somewhat favorable for fire. It is a declaration that the atmosphere has assembled a dangerous combination of ingredients and that any ignition could become difficult to control quickly. It is an operational warning, not decorative language. When those warnings spread across enormous multi-state areas in March, that should force a reset in how the season is being understood. Because what the landscape is experiencing is not a bit early for fire season. It is fire season behavior already in progress. But the real depth of the danger comes from something even less visible than the humidity reading or the wind speed, fuel curing over time. This is where the event becomes far more serious on day 3 than it was on day 1. And this is one of the most important ideas in the whole script, because it explains why a multi-day event is not just the same danger repeated. It is danger maturing. On the first day of extreme dryness, surface fuels lose moisture first. Those fuels matter. They are easy to ignite, and they help fire spread quickly, but they are only the beginning. If the dry air and wind continue into the next day, the drying penetrates deeper into the fuel bed. More structurally significant plant material begins to lose moisture. Stems that would have resisted ignition earlier become more receptive. Slightly denser fuels begin moving toward a more combustible state. By the third day, what was once merely dry at the surface begins to look dry through more of its structure. That is why the danger is not linear. Day 3 is not merely 3 times as bad as day 1. The fuel environment itself is changing character. What might have started as a highly flammable surface layer can become a much more energetically dangerous landscape. This is exactly why multi-day low-humidity events with wind are so feared. The atmosphere is not simply creating temporary conditions, it is preparing the fuel. And once you understand that, the phrase, "the land is ready to ignite," stops sounding dramatic and starts sounding mechanical, because at that point, ignition energy requirements drop. It takes less to start a fire than it would have taken earlier in the week. A spark from machinery, a power line fault, a dragging chain, a cigarette, a small accidental flame. Under ordinary conditions, some of these might remain minor or fail entirely. Under critically cured fuel and strong wind, they can become the beginning of something much larger. This is where overnight recovery becomes crucial, and where the current event becomes even more troubling. Under normal spring behavior, a hot, dry afternoon can still be followed by a cooler night that raises relative humidity and lets fuels partially regain moisture. That overnight recovery matters immensely. It does not erase the danger, but it gives the landscape a chance to slow down. It gives vegetation a chance to absorb some moisture from the air. It gives firefighters a better operating window. It gives the system a pause. But when nights stay too warm and the air mass remains too dry, that pause weakens or disappears. Fuels that should be recovering continue to sit in moisture deficit. Fine grasses that should be softening slightly overnight remain crisp and ignition-prone by dawn. Suppression work that normally benefits from calmer, more humid nighttime conditions becomes harder and less effective. Every sunrise arrives with the landscape already stressed instead of partially restored. That means the next day's fire weather does not begin from zero, it begins from accumulated damage. And that is when the event starts feeling dangerous, in a way people can underestimate until it is too late. Because the map may show a broad warning area, but what it really represents is a giant zone in which ignition has become more consequential than usual. The danger is no longer concentrated in one visible fire. It is distributed across potential. Across roads, power, infrastructure, ranchland, fields, edges of towns, dry ditches, equipment yards, and open country. The atmosphere has created a region where trivial causes can have outsized outcomes. This is the part of the story that moves the event out of the realm of meteorological fascination and into the realm of immediate public hazard. A temperature anomaly can feel abstract until it breaks something obvious. Fire weather is different. Fire weather is a countdown without a visible clock. The dangerous part may not be what is already burning. It may be what has not ignited yet. That is the psychological burden of these setups. The landscape looks ordinary right up until one point of ignition reveals what the atmosphere has been preparing for days. So when people hear that heat, humidity, wind, and fuel are all aligning at once, they should not picture 4 separate warning boxes being checked on a chart. They should picture a landscape being engineered toward a faster, more violent response to ignition. Because that is what these ingredients are doing together. The heat lowers margin, the dry air extracts moisture, the wind accelerates spread, the fuel stores the consequences. By the time all 4 are aligned, the atmosphere has done most of the preparatory work already. That is the real threat sitting inside this March event. Not just that it is hot, not just that it is early, but that the heat has arrived with the exact partners required to convert an atmospheric anomaly into a combustion problem over a huge region. And once that conversion has begun, the next question becomes even more serious. If the fire environment is now this receptive, why have the forecasts seemed to run slightly behind the full edge of what the atmosphere is delivering? Because that gap, small on paper, but important in practice, maybe telling us something larger about the limits of the tools we are using to anticipate events like this in the first place. At this point, the question is no longer whether the event is dangerous. The danger is already visible. The question is why the atmosphere seems able to keep landing slightly beyond the forecast edge during the exact kind of setup where accuracy matters most. Because if this were only a matter of one city running a little hotter than expected, it would not deserve much philosophical weight. But when a broad heat and fire weather pattern keeps revealing a lived reality that feels just a step ahead of the forecast framing, the issue becomes bigger than 1 week. It becomes a question about whether the predictive systems are being asked to describe an atmosphere that is changing its behavior faster than those systems can comfortably summarize. There are a few grounded, physical reasons this can happen, and it is important to walk through them carefully. The first is terrain and air movement. When air descends from higher elevations, especially under dry conditions, it compresses and warms. That process is basic atmospheric physics. It is not controversial, and it is not exotic. But in a large event stretching from the Rockies into adjacent plains and basins, the cumulative impact of descending, warming air can add meaningful heat at the surface. Models account for this in a general way, of course. The issue is that during a strong ridge event, where everything is already biased toward additional warming, small underestimates in compressional heating can become more significant than usual. The second is sky condition and solar loading. Under a powerful ridge, cloud development is suppressed. Day after day of unusually clean, stable, cloud-free skies can allow more solar energy to reach the surface than a more average setup would. Again, models absolutely include radiation physics. This is not a matter of them forgetting the sun exists. The deeper problem is that extremes are often where several small conservative assumptions line up at once. Slightly too much cloud expectation, slightly too much smoothing of local terrain effects, slightly too little surface amplification under dry conditions, and the atmosphere ends up beating the forecast by 2 or 3 degrees, often enough for people to notice. That is how these misses should be understood, not as catastrophic failure, as stacked underestimation. A little low here, a little low there, a little too restrained in how the model imagines the surface and lower atmosphere will reinforce one another under a locked-in ridge. Most of the time, those small gaps do not matter much, but near the edge of the distribution, where records, health, stress, and fire danger all live, they matter a great deal. The closer the event gets to critical thresholds, the less room there is for only a small miss. And then there is the more structural possibility, the one that makes this event feel like more than a one-off forecast annoyance. Weather models are built on physics, but their real-world usefulness depends heavily on being calibrated against long records of observed atmospheric behavior. Those historical records define what the model considers ordinary, uncommon, rare, and extreme. If the atmosphere begins spending more time in highly amplified, strongly ridged, very warm states that were less common in the calibration history, then the model can remain technically sound while still leaning slightly conservative near the upper edge. That is the possibility people should take seriously here. Not that the science is broken, not that meteorology has failed, but that the atmosphere may now be visiting the far edge of the old range, often enough that the old range is becoming a less reliable emotional guide. In other words, the model may still be describing the climate record accurately, while the lived present is beginning to spend more time near conditions that the record still treats as very rare. The map is correct. The territory is changing. That is an uncomfortable idea, because it suggests a subtle but important lag between expectation and reality, and when that lag appears during a dangerous event, it changes how warnings are felt and acted on. A forecast that says 83 when the day ends up 85 is not just a technical miss. It is an example of the upper edge arriving higher than advertised. The difference sounds small, but thresholds in the real world are often sensitive. Fine fuels dry faster. Stress accumulates earlier. Response windows shrink. The event begins behaving less like the version people thought they were preparing for, and more like a harder-edged version that showed up anyway. But even that does not fully explain why this setup has felt so oppressive. To understand that, you have to go back above the surface and return to the thing that should have moved the whole pattern along by now. Because intensity alone is not what makes this dangerous. Persistence is. And persistence is where the jet stream comes back into the story. The jet stream, in the simplest useful sense, is the atmospheric conveyor belt. It is what helps keep weather systems from sitting on one place long enough to wring out their worst consequences. Heat waves move on, storms move on, cool shots move on. The atmosphere refreshes itself partly because the larger flow does not let one regime dominate one region forever. That is one of the most important hidden protections in mid-latitude weather. Motion is mercy. What is disturbing about a blocked ridge is that it takes that mercy away. The conveyor belt slows. The pattern does not progress as quickly as expected. The hot side of the map remains hot. The dry side remains dry. Nights remain too warm. Fuels remain exposed. The atmosphere stops behaving like a passing event and starts behaving like a pressure being applied without release. That is what has given this March pattern so much of its menace. It has not just formed, it has stayed coherent long enough for consequences to compound. This is where the larger scientific debate becomes relevant. Over the past several years, one of the central questions in atmospheric science has been whether the jet stream, in at least some circumstances, is becoming more prone to deeper meanders and more persistent blocking behavior. One proposed explanation involves Arctic amplification, the fact that the Arctic has been warming faster than the global average. The logic goes like this. If the Arctic warms faster than lower latitudes, the temperature contrast helping drive a stronger, straighter jet stream weakens. A weaker contrast may allow the flow to become slower, wavier, and more vulnerable to getting stuck. That idea is appealing because it has a clean, intuitive structure. A steeper gradient drives a faster river. A weaker gradient allows more meander. And in atmospheric terms, a more meandering flow is exactly the kind of environment where blocking ridges can become more persistent. That, in turn, is exactly the kind of environment where heat waves, cold outbreaks, and flood-producing patterns can stay parked long enough to become much more damaging than they would be if they moved through quickly. But this is where intellectual discipline matters. The debate is not settled. Serious scientists disagree about how strong the observational evidence is, how detectable the signal is over the noise of natural variability, and whether Arctic amplification alone can explain the blocking patterns people are now worried about. Some researchers see a meaningful relationship. Others see a signal that is weaker, noisier, or less conclusive than the broader public discussion sometimes implies. So the responsible way to handle this is not to oversell it. It is to say that the hypothesis is plausible, important, and under active study, but not fully resolved. What is far less disputed is the consequence of blocking once it happens. That part is not theoretical, we have seen it. The Russian heatwave of 2010, the major European summer heat events, the Pacific Northwest heat dome of 2021. These are all reminders that persistent atmospheric structures can be more destructive than short-lived extremes that briefly reach even higher peaks. Duration deepens impact. Duration widens the affected population. Duration stresses infrastructure harder. Duration dries landscapes further and strips away recovery. That is why historical analogues matter here. Not because this March event is already identical to the worst modern disasters, but because it is showing the same behavioral trait that made those disasters so damaging. It lingers. It keeps applying the same pressure. It turns a pattern into a burden. And when that burden arrives in March, it creates a different kind of psychological shock. People are not supposed to be that deep into the season's stress logic yet. The land is not supposed to be that deep into its heat logic yet. Fire weather is not supposed to be this mature yet. And still the pattern has behaved as though it has permission to skip ahead. That is what makes this event feel like a warning and not just an outlier. The models have seemed slightly conservative at the upper edge. The ridge has been stronger and more stubborn than many people are comfortable seeing in March. The jet stream configuration has allowed the system to hold its shape long enough for real-world danger to increase. And once you put those pieces together, the story begins to extend beyond 1 week of bad weather. It becomes a question about whether the atmosphere is entering the warm season, already carrying the structural habits that make the worst summer events possible, which leads directly into the next, and perhaps most unsettling point of all. This is happening before the full summer engine is even engaged, before the strongest seasonal amplifiers are fully in place, before the longest days, before the deepest landscape drying, before every familiar source of heat season escalation has switched on completely. And that means the event should not be read only as a March anomaly. It should be read as an early demonstration of how high the atmosphere's risk ceiling may already be. One of the most important reasons this event should be taken so seriously is that it is happening before many people would expect the atmosphere to have access to its full warm season force. That point cannot be repeated enough. The calendar still says early spring. The strongest solar angle of the year is still ahead. The deepest seasonal drying is still ahead. The cultural mindset of "this is when the real heat starts" is still ahead. And yet the atmosphere has already shown that it can build an event with summer-grade behavior now. That is why the larger background context matters. Big heat events do not happen in a vacuum. They happen inside broader climate patterns, seasonal transitions, soil moisture conditions, ocean temperature states, and long-memory atmospheric tendencies that shape how the warm season unfolds. And what makes this moment so unsettling is that the current event does not appear to require every major amplifier to already be fully switched on. In plain language, this may not even be the atmosphere, using all of its strongest tools yet. That matters especially when you consider the role of large-scale climate variability such as ENSO, the El Niño Southern Oscillation. ENSO is one of the most powerful year-to-year climate influences on the planet. It affects rainfall patterns, storm tracks, drought development, and seasonal warmth across huge parts of the world, including North America. When El Niño is established, the atmospheric circulation tends to reorganize in ways that can significantly alter heat and precipitation patterns. When La Niña is in place, a different set of tendencies often appears, and when the system is in a more neutral phase, the atmosphere is not receiving the same kind of large, obvious, ocean-driven push that people often associate with stronger seasonal anomalies. That is part of why this event deserves such close attention. It is not arriving in a moment where every major climate signal is screaming in the same direction. It is not a case where people can simply say, well, of course it is hot. The big, warm phase ocean pattern is already fully boosting everything. The deeper discomfort is that the atmosphere is producing this kind of early season extreme behavior without needing the simplest, most familiar explanation. This is not the full engine running at maximum visible output. This is what the system can already do while still early in the seasonal sequence. And once you see it that way, the story changes again. It stops being about whether this week is remarkable. That part is obvious. The harder question is what this week says about the structure of the months ahead. Because if an atmosphere in early spring can already produce 99th percentile ridging, June-like warmth in March, deeply concerning fire weather ingredients, and repeated forecast underperformance at the edge, then the idea that there is still plenty of time before the dangerous season starts to sound less like wisdom and more like habit. This is where seasonal calendars become part of the story. Not the wall calendar in your kitchen, the deeper calendar that societies use without always realizing it. Fire agencies have seasonal staffing rhythms. Utilities have maintenance and preparedness rhythms. Public health systems have seasonal messaging rhythms. Farmers, ranchers, and local communities all operate with built-in assumptions about when certain categories of danger usually begin to matter. Those assumptions were not invented at random. They were built from long experience. But long experience can become a liability if the season starts changing faster than the systems built around it. That may be one of the quiet warnings inside this event. March has traditionally been treated as transitional in many of the affected regions. Not harmless, not fully stable, but still transitional, a bridge month. A period when late cold and early warmth can compete, but not a month most people emotionally place in the same category as the worst fire weather or the harshest sustained heat. If March can now deliver this kind of setup heat pressing into summer territory, atmospheric structure near the top edge of the historical record, multi-state fire weather danger, then the old seasonal map in people's heads may be becoming less reliable. That does not mean every future March will look like this. It does not mean the warm season has simply swallowed spring whole, but it does mean the old spacing between transition season and danger season may be shrinking, and that matters because societies do not only respond to weather, they respond to expectations. People act according to what they think the season permits. They postpone concern when the calendar tells them it is still early. They delay preparation when the most dangerous chapter of the year feels like it belongs to a future month. In that sense, timing itself becomes part of the risk. This is also where the broader framing of anomalies matters. During weeks like this, there is always a temptation to gather every strange thing happening at once: space weather, unusual sky events, earthquakes, volcanic headlines, near-Earth objects, solar noise, and turn them into one giant mood. Emotionally, that is understandable. Weeks like this do feel loaded. They feel like too many systems are raising their hands at once. But the strongest version of this story does not need to force all those things into a false shared explanation. In fact, the more disciplined the narrator is here, the stronger the piece becomes. Because the true power of this event does not depend on speculative connections. It already stands on its own. A March heat and fire weather setup this organized, this early, and this large is enough. The atmosphere does not need help from unrelated mysteries to become alarming. The real task is not to link everything, It is to know what deserves to remain separate and still explain why the central pattern is serious. So, if broader anomalies are mentioned at all, they should remain what they really are in relation to this story: context for the emotional atmosphere, not the thesis itself. The thesis is simpler and stronger. The atmosphere over the United States is already capable of producing a summer-style danger profile in March, and the systems meant to capture that profile seem at times to be arriving slightly behind reality. That is the line worth protecting. That is the line that should stay sharp, because once that line is clear, the implications widen quickly. Forecast lag is not only a meteorological issue, it is a societal issue. A society can often adapt to known risk if the warning comes early enough and clearly enough. But when the upper edge of an event keeps landing a little hotter, a little drier, a little more persistent than expected, the response system loses margin. Communities prepare for one version of stress and meet a harder one. Fire agencies face fuel behavior that matures faster than the public understands. Residents hear record warmth, but live through something closer to a seasonally displaced stress test. That is why even a modest forecast underestimation can matter so much in a setup like this. The danger is not that the forecast is useless. The danger is that small, low-end bias at the top of the distribution can make the real event feel like it arrived sharper than advertised. And when that happens repeatedly, it forces a larger question into view. Are we still treating the old tale of the distribution as though it was safely far away when, in practice, the atmosphere is now reaching it more easily and earlier? That is the most unsettling idea in the entire event. Not that this week is bizarre. Bizarre weeks happen. Not that records may fall. Records always fall eventually. The deeper issue is whether the outer edge of the old system is becoming easier to access. Whether what used to be the thin statistical tail is beginning, season by season, to lean closer to the lived center of experience. Not fully normal yet, not constant, but less distant, less unreachable, less safely confined to rare chapters in the archive. If that is true, then language itself begins to lag. We keep calling things anomalies because the older record taught us to. We keep talking about unseasonable heat because the calendar taught us to. We keep using the emotional vocabulary of exception long after the atmosphere has started making those exceptions easier to produce. And that is how societies get caught between data and adaptation. The world changes first. The definitions come later. So this is what the event may really be warning us about. Not just hotter weather, not just a bad March, but a shrinking gap between what used to be considered extraordinary and what the atmosphere is increasingly willing to deliver as an opening move. A shrinking gap between seasonal expectation and real-world exposure. A shrinking gap between forecast framing and lived impact. That is why this week should not be filed away merely as a strange spring headline. It should be read as a stress signal. The atmosphere has shown that it can bring summer-grade heat behavior into March, pair it with dangerous fire weather ingredients, and hold the pattern in place long enough for consequences to accumulate. That is already enough to change how the rest of the season should be watched. And once you accept that, the final question becomes unavoidable. What kind of warning is this, exactly? Is this the sort of event that will be remembered precisely because it was so unusual? Or is it the sort of event people will one day look back on as an early clue? One of those moments when the atmosphere quietly showed that the categories were shifting, that the seasonal boundary was moving, and that the old definition of too early for this was beginning to lose its meaning? So what kind of warning is this? That is the question everything in this story has been quietly building toward. Not whether this week is remarkable, that part is settled. Not whether the temperatures are strange, they are. Not whether the fire weather setup is serious, it clearly is. The deeper question is what category this event belongs to in the larger story of the year. Is this a freak early season outlier, one of those rare atmospheric episodes people will remember precisely because it arrived so far outside the expected order of things? Or is it something more consequential than that? An early demonstration, a preview, a signal that the atmosphere is now capable of entering the warm season with more force, more organization, and less delay than our old expectations were built to handle. There is no honest way to answer that with total certainty yet. That uncertainty has to be respected. One event is not the whole climate record. One March does not rewrite the entire seasonal system by itself. And responsible science means refusing to turn a powerful warning into a simplistic prophecy. But uncertainty is not the same thing as reassurance. In situations like this, uncertainty can actually sharpen the warning rather than soften it, because what this week has already shown, beyond any argument, is that the atmosphere's early season ceiling may be much higher than people still instinctively assume. That is the part that should stay with you. March has already demonstrated that it can host June-style heat in parts of the United States. It has already demonstrated that a blocked pattern can build and hold long enough to create real compounding danger. It has already demonstrated that heat, low humidity, wind, and fuel readiness can align over a vast area before many people have psychologically entered the dangerous season. And it has already suggested that forecast framing, while still highly valuable, may sometimes be arriving slightly below the upper edge of what the atmosphere is actually prepared to deliver. That combination matters. It matters because it changes how the rest of the year should be watched. It changes how early should be interpreted. It changes what people mean when they say the season has not started yet. Because maybe the season, at least in its most consequential atmospheric sense, does not begin where people still think it begins. Maybe the line between spring and summer is no longer where the old calendar placed it. Maybe the atmosphere is already moving that boundary around. And if it is, then the real risk is not only physical, it is cognitive. Systems built for one seasonal rhythm may lag behind a new one. Communities may still be waiting for the familiar signals that tell them to switch into a higher state of readiness. Agencies may still be calibrated around a timetable that assumes a wider buffer between transition season and danger season. Individuals may still be hearing unseasonable and mentally translating that into temporary oddity, when what they are really seeing is a system that now reaches extreme states earlier than it used to. That is how vulnerability grows. Not only through bigger numbers, but through delayed recognition. Not only through stronger heat, but through a mismatch between expectation and exposure. When people think the dangerous part of the year is still ahead of them, they do not always understand that they are already standing in it. And that may be one of the quiet truths inside this event. The atmosphere does not care when humans have decided a season is supposed to begin. It operates according to structure, energy, and conditions. And this week, those conditions came together in a way that should make the rest of the warm season feel less hypothetical and more immediate. So no, we do not yet know exactly what July will look like. We do not know whether this event will end up standing alone in its intensity, or whether it will be followed by a series of similarly aggressive patterns through the hotter months. But that is not the only question worth asking. Another question matters just as much. What has this week already proven? It has proven that the atmosphere can still surprise us on timing. It has proven that spring can now host a danger profile many people still mentally reserve for summer. It has proven that the upper edge of the system is closer than it looks when viewed through old seasonal assumptions. And it has proven that when those extremes arrive early, they do not arrive as curiosities. They arrive with consequences, heat stress, fire potential, forecast strain, and a landscape that begins changing under them in real time. That is why this event deserves to be remembered even before we know everything that follows it. Because some weather events matter only for what they do in the moment. Others matter because they reveal a capability, they show what the system can do. They alter the range of what people must now treat as plausible. This feels like that kind of event. Not simply a headline, not simply a record chase, a demonstration. And demonstrations change the future even when they are brief. Once you have seen what the atmosphere can do in March, you cannot unsee it. You cannot go back to assuming that the dangerous season begins neatly later. You cannot fully trust the old comfort that says there is still time before the real strain starts. The event has already taken that comfort away. It has already shown that the opening act can carry more force than many people thought possible. So perhaps that is the clearest way to end this story. The most alarming thing about a 99th percentile event is not only the event itself. Events happen, records break, extremes visit and pass. The more alarming thing is what that event suggests about the shape of the distribution behind it. Whether the old tail is staying safely distant or whether it is inching closer to the center of lived experience, season by season, month by month, until one day, what once felt extraordinary begins to feel less like an exception and more like a recurring chapter. If that is what is happening, then the real meaning of this week reaches beyond one burst of March heat. It reaches into how we define seasons, how we prepare for risk, how we interpret forecasts, and how quickly we are willing to admit that the atmosphere may no longer be reading from the same script we thought it was. And that is why this heatwave matters. Not just because it is severe, not just because it is early, but because it may be showing, in the clearest possible terms, that the distance between what used to be considered exceptional and what the atmosphere can now deliver is getting smaller. If this is what the system is willing to do before the season has fully begun, then the real story is no longer this week alone. The real story is how much closer summer's most dangerous behavior may already be than we still want to believe.